This is page 2 of your exponential functions test review. Number 9 says, mark the graph as growth G or decay D. So looking at this graph here, I know that we read left to right, so we're going to read a graph the same way. From left to right, is it increasing or decreasing? This one is showing a increase. So from left to right, it's going up, which means that this is a growth. So we're going to put G. Number 10 says, do the following functions represent growth G or decay D? So in order to find the growth or decay for these is to look inside the parentheses. So we're looking here at these two numbers. Okay. Now the key here is, what is it, greater than 1 or less than 1? So that's going to be the key. For growth, you're always going to see 1 point a number. For decay, you're going to see 0 point a number. But with it being fractions, how do we know if it's 1 point or 0 point? Well, just go to Desmos and type this fraction in. So 2 divided by 5 gives me 0.4. So we're going to put equals 0.4. If it's below 1, it has a 0. This is a decay. So now we're going to do the same thing with the next one. So we're going to do 4 divided by 3 in the calculator, and it gives me 1.33 repeating. So this is equal to 1.3. Anything with a 1 is a growth. Number 11 says, the function f of x can be used to estimate the value of a bar of silver after x years. Which of the following two statements are true? So here it says the initial value of the silver is 4,000. So the initial is the number in front, and it is not 4,000, it's 400. So A is incorrect. B says the growth factor of the silver's value is 35%. So the growth factor can be seen from inside the parentheses, like we talked about in number 9. So it is growing because growth is anything with a 1. So this is a growth, but what is the percent that it's growing by? It's not 35%. Here's how we figure that out. I take that 1.035 as a decimal, and to turn it into a fraction to see, so we're going to completely disregard this 1 here, to see what I added onto it, we're going to move this decimal back forward 2 places right here. So when I move it forward, I'm left with 3.5. This is changing it back into a percent. So it was not increasing by 35%. It increased at a rate of 3.5%. So C is actually the correct one. But remember, we're picking 2 true statements. So D says the initial, or the value of the silver after 2 years is 428.49 cents. So let's see. So we're going to use the function that they give us. You can do this a couple ways. So the way I'm going to do it initially is type in the full thing, f of x equals 400 times 1.035 to the power of x. And you can make it into a table, so cogwheel table, and we're looking for after 2 years. So this is 0 years, the start. This is 1 year, and here this is 2 years. At 2 years, it equals 428.49 cents. So D is also the correct answer, the second correct answer. The other way you could have done this is to just type in, without f of x, you're going to type in 400 times the common multiplier, and the x represents the number of years. So if you're looking for 2 years, type in to the power of 2, and it gives you the same number. So 2 ways you could have done that. Number 12 says choose from the box below each blank to complete the function that best represents the graph. So remember that the first blank is going to be your starting amount or your y-intercept. We talked about that on page 1. So here's your y-axis right here. So where is your y-intercept? It looks about here, close to 10. Now, obviously, there's no 10 here, so we're saying which one best represents. So which one's closest to 10? That would be 9.2. So we're just estimating the best fit, which is close to 10, so 9.2. Then inside your parentheses here, this is your rate. So what is it going up or down by? Okay, now the best way to look at this is look at these numbers. Inside the parentheses tells me growth or decay. So let's start with identifying. Is this growth or decay? This one is decay. Okay, we're going to skip 1, but that would be a 1.25 is a growth. So just the numbers alone tell me growth or decay. Now, the graph here, is this a growth or decay? This one's a decay. We read left to right, and it's decreasing. So it's a decay, which means my answer has to be 0.75, which has a 0 in front of it. It's just invisible, so 0.75 is my answer. This next part is extra practice, so I'm just going to quickly go through giving y'all helpful tips, but I'm not going to solve these because I want y'all to get the extra practice in. So, number 13 says create an exponential function that best models the situation. Anytime you see best models, you're going to use a regression. So a regression means you're going to, step 1, type into Desmos. So I'm just going to write out your steps here. You're going to type this into Desmos for step 1, all of the numbers, the whole thing. Then step 2, you're going to run a regression, so that's y1 tilde a times b to the power of x. And don't forget that other 1 there. Once you get that, you should get an a value and a b value, and that's what's going to go here. A is going to go here, b is going to go here in your parentheses. So that should help you complete 13. Number 14 says, what is the equation of the asymptote of the graph of the function f of x equals? So keyword here is asymptote and equation. So in order to write an equation, we have to have an equal sign. So you're going to have an equal sign here. Okay, how do we write an asymptote? Go look at your notes from Monday when we talked about key attributes. Okay, an asymptote is a line that kind of looks like this, and it never touches. So where does your graph start to go flat and never touch? That's how you're going to write the equation for this. Number 15 says examine the function and complete the table and fill in the blanks. So when it asks for the domain is going to be from, domain is x, so you write x in the middle. 2 inequality signs on the side. Domain is left to right. So how far to the left does it go on my domain? How far to the right does it go? And remember, if it never stops, we call that infinity. Okay. Next part is your range. So range is y in the middle, two inequality signs on the side. Range is bottom to top. So take your pencil. Once you've got this graph on Desmos, where's the bottom? Where does it stop? And where is the top? Where does it stop? Okay, and if it doesn't stop, it's an infinity sign. Next is the common multiplier. So in order to find the common multiplier, it's going to be, you can put in your points into the table here, fill them in if that helps you better, and you're just going to find what are we multiplying by, okay? Or you can also find the common multiplier by looking at your function that they give you. So here you can find the common multiplier. You can also determine just from looking at this, is this a growth or decay? We talked about that on number 9 or number 10. The next part is the y-intercept. So there's two places you can find the y-intercept. The y-intercept can be found here and here. Then it says the equation for the asymptote is, so again, we just talked about the asymptote in number 14. So the equation, so when you write an equation for something, we're going to have an equal sign in the middle. And if you need help, go look at Monday's notes about key attributes of how to write an asymptote. Number 16 says, which of the following scenarios does the function best describe? So when we're talking about a function, the 800 is going to be our initial value or cost of something. So all of these say that a computer is worth 800. They all start with 800, so I can't eliminate anything just yet. But the next part is different. It's saying it's increasing, decreasing, increasing, or decreasing. How do I determine that? I determine that from the number inside of my parentheses. Is 0.75 increasing or is that decreasing? We talked about that on number 10. And then you have to determine by what percent. Remember, you always have 100% and then you either add or you take away. Number 17 says, which function below best represents a beehive that begins with 2 bees and triples in size every week? So it begins with 2 bees. So remember, 800 is what you begin with for a computer. This one, you begin with 2 bees. So here's your hint. You begin with 2. You begin with 2. You begin with 2. C does not begin with 2, it begins with 3. Then your next hint is that it triples in size. So triples, what does triples mean? And that's going to be every week. So that's going to be your little exponent.